Hello students, in this video we'll discuss present value calculations for insurance products. If we consider whole life continuous insurance, then we know this is a random variable z, which is new to the tx, the future lifetime. If we compute the expected value of this, we need to recall. So recall the PDF of tx is fxt, and we can write this as pxt mu x plus t. It's the survival function times the force of mortality. So if we compute the expected value of this random variable z over here, we know previously that this is ax bar, and that will be the integral from 0 to infinity of e to the negative delta t, that's my discount factor, and then t px mu x plus t dt, that's my PDF. So we can break up this integral into three terms. So what we have over here is this is our present value factor. So you bring back the value of $1 with interest. This is the survivalship. And this is the force of mortality. So a person who has survived up to age t, who is currently age x, survives to age t, and then at that instant, the person dies, and we get a $1 payment at that time, so we bring that particular time back with interest, and we get this formula for our present value of an insurance function. Now for discrete, we have something similar. If we consider end of year, whole life, then z, the random variable, is new to the kx plus 1. And so the expected value of this random variable will be the following. So the expected value of this, so a, x with no line above it, is for the non-continuous discrete. It will be the sum. K goes from 0 to infinity. I can put either an e to the negative delta here, or I can do new, so I'll write this as new to the k plus 1, that's the discount factor. And then I have k qx, which we can write in several different ways. We can write this also as the sum. K goes from 0 to infinity of new to the k plus 1, that is my discount factor. And then we can write this as k px minus k plus 1 px. And often what is important to note is that for the first term in this discrete insurance, we have the following relationship. So the first term in this insurance will be, write this down, we'll have a new, and then we'll have a 0 qx plus the sum, k goes from 1 to infinity, of, what this is, new to the k plus 1, and then k qx. Now, this probability is the probability that a person age x survives 0 years and then dies the next year, so that's just plain old qx. So this is new qx plus the sum, k goes from 1 to infinity of new to the k plus 1. And then what we'll have over here is we'll write this as, in terms of other survivorships, we'll write this as you survive for k years, and then you are age x plus k, and you die in that next year. Now what we can do is we can re-index this sum over here, and then we can pull out one factor of new, and we can take this over here. We can note that k px is going to be a px. You do survival for 1 year, and then you have px plus 1, and then what goes over here is k minus 1. So you have a k minus 1 px plus 1. So this is px, k minus 1 px plus 1. And so I'll pull out a factor of px and a factor of new. And so what we can do is we can write this now as new qx plus new px times the sum. K goes from 1 to infinity of new to the k, because I pulled out one of the news. And I pulled out one of these px's over here. I'm left with a k minus 1 px plus 1. And then over here, I'm going to have a qx plus k. So qx plus k. And so now what we can do is we can observe that this is new qx plus new px. And then I'll re-index this sum. The sum, k, goes from 0 to infinity. So I'm going to subtract 1 from k. So that means I have to add 1 to all of these k's. I'll have a new to the k plus 1. I'll have a k px plus 1. And a q of x plus k plus 1. And so if we examine this, what we have is the following. We have this x plus 1 over here. And we have an x plus 1 with a k, with a k, with a k, plus 1. And so this term over here is just, this is whole life discrete insurance for age x plus 1. And so finally what we get is we see from this relationship that we've driven that ax, so this over here is just ax plus 1. And so now we have the following recursion formula. The formula is that ax is new qx plus new px ax plus 1. This is my one-step recursion formula for discrete whole life insurance. Thank you very much.